The additive manufacturing process enables us to manufacture parts that we cannot manufacture today with normal, traditional manufacturing processes. That enables us to be more ingenious in terms of how we design our turbine blades, how we cool them and how we life them.
Turbine blades has always been, I feel like, a vision. It's a real target. It's the most challenging area of the turbine. So if you can print a turbine blade, you can pretty much print anything. And we've proven over the last couple of weeks now that we have been able to print a turbine blade and test it in an industrial gas turbine engine.
In Lincoln, we're testing a 3D printed blade, and we believe this is special because it's the first time anywhere in the world this has been tested at full load conditions in a gas turbine. We test these blades very quickly. In 1 hour, we run the engine at full load. We put a probe in here to measure the material temperatures, which tell us how long these blades will last in a turbine.
Now, the turbine blade itself is this particular blade. Now, this is the high pressure turbine blade of a 13 megawatt SGT 400. Typically, we have to do all of the design, analysis, the aerodynamics, the work in terms of heat transfer on this blade 2 years before we can actually then understand in an engine how it's actually going to perform. What additive manufacture does, and this is the additive manufacture blade that we've actually tested in this engine, this gives us the ability to cut that lead time down from 2 years down to 2 months.
It allows us to create new designs, to get more efficient engines, more efficient designs into our turbines, tested and then onto ultimately our customers.
We will see quicker development times.
You don't need this very expensive tooling in order to make your products. So that makes additive manufacturing perfect for design modifications. You'll get there much quicker.
The basic process starts with receiving the model from the customer. We'll then take that model and slice it into very thin layers and export it to the machine. The machine then builds it up in a very thin layers, 20 microns, using a laser to melt all of the metal powder together to create the final product. Although we've been developing the technology for 10 years, we're still very much at the beginning of the journey of what this technology is capable of. To a certain extent, if you can design it, we can make it.
None of this would have happened without the tremendously close collaboration between a large number of Siemens units. It really is ingenuity for life to enable us to satisfy all of our customer needs.
This is Tom. He's 45 years old. Tom is a maintenance engineer at a large manufacturing company. For 2 decades, his job has been to ensure that the machines operate as smoothly as possible. Until recently, his day-to-day work was characterized by tasks with tight time frames. Maintain the machine, quick, then check whether the process runs as required. He often felt rushed. Tom's employer has recently installed a predictive maintenance solution, something Tom greatly appreciates. Why? Imagine the machinery can send a message saying that a problem is brewing. The important thing is, the machine is still running. How does this intelligence work? In our example, the machine dispenses thermal conduction paste. By continuously analyzing production data, it detects that the target temperature cannot be reached. It consults the quality database and identifies the appropriate parameter set to get the machine back into stable operation. Tom approves its application. The machine adjusts itself accordingly. In the second case, the machine also detects that the temperature is deviating from the target state. It is steadily decreasing. This time, the data analysis reveals that the heating circuit is no longer functioning correctly. The circuit must be exchanged within the next 2 days. Tom can now organize a replacement part in time. This avoids losses in dispensing quality and machine downtime. Once the heating circuit is replaced, the system tests itself. Tom can put the machine back into operation immediately and close the ticket on a positive note. Ever since Tom's employer installed the predictive maintenance solution, Tom can focus on solving the problems that require his wealth of experience. The solution offers him a transparent maintenance process. Tom is still fully in the lead of the production process. Now, finally, he can work on improving the system by continuously supplementing the expert database with newly identified solutions. Working to tight timeframes is a thing of the past for Tom.
The fourth manufacturing revolution is going to boost industrial productivity by at least 30%. It presents a $1 trillion opportunity. Tech Mahindra is helping modern enterprises harness the power of artificial intelligence for reducing machine failure, improving quality control, increasing productivity, bringing down the cost of the product substantially, turning your customers into subscribers of new services, creating new opportunities for manufacturers in areas like customer service, maintenance, marketing, logistics, and many more, powered by unique insights from unstructured data by leveraging our cognitive text extraction engine. Helping manufacturers run smart customer care, smart dealerships, and smart experience centers for the connected customer using Intelio, our in-house chatbot platform. With Tech Mahindra, manufacturers can now offload the risk of several hours of manual effort in inspecting extremely sensitive and high-cost equipment by deploying drone-enabled cognitive inspections. They can now get a dashboard view, providing immediate insights to human supervisors. Through the Acumus Marketplace, Tech Mahindra offers pre-built AI models that link to employees while handpicking the right partners to develop enterprise solutions to transform business operations. Tech Mahindra's engineering team leverages AI with technologies like advanced robotics and 3D printing. We are helping build factories of the future, which are agile, flexible, and capable of operating on customized multi-product requirements. Tech Mahindra's AI-based automation is empowering manufacturers to achieve up to 80% effort savings with higher accuracy. Bring in next-gen manufacturing with Tech Mahindra. Future Rise with Tech Mahindra.
Industry 4.0 with Bosch Rexroth. Example of an assembly line for the production of an industrial control with 3 automatic and 2 manual stations. An RFID tag connects the conductor board with the order saved in the company software. Every station reads the RFID tag and receives all of the instructions about which processing steps are necessary. Therefore, the product steers itself through the plant. The application of heat-conducting paste is simulated in the first station. A motion logic system from Rexroth controls the Cartesian robot. At the same time, it records relevant process parameters and forwards them to a local or cloud-based analysis system. Here, a Delta robot places a cooling element on the conductor board. Rexroth already fully relies on model-based engineering during machine development. Because of this, users can virtually test and optimize all relevant production processes in advance. Using the web connector, the same operating interface can be used on different devices, from a machine display to a standard tablet PC. An articulated arm robot now attaches the heatsink. The robot is intelligently networked with the Rexroth control system. The robot guides a cordless Nexo nut runner that records all tightening data and transfers it to the process quality manager. The software recognizes deviations and archives all of the information so it can be traced later in the cloud. Now the component moves to an intelligent manual workplace. There, digital assistance systems guide employees through the assembly process. A projector displays the work instructions onto the table. The components to be installed are visually highlighted using Pick to Light. Individual work processes are confirmed by the employees using virtual switches on the workspace. During this process, 3D cameras check every hand movement. Thanks to this technology, manual workstations with Active Assist significantly shorten the employee training period, allowing for custom assembly processes. Rexroth also integrates existing machines into networked production environments, such as this testing station. Sensors measure all operating conditions. The i4.0 connector forwards this information to higher-level systems. With this solution for brownfield plants, users protect their investments and can convert to a connected solution with minimal effort. Active Cockpit, an interactive communication platform, filters and visualizes all relevant production data. This creates the highest degree of transparency and makes all data available to the employees as required. The data analytics server analyzes the machine data for detailed remote condition monitoring and therefore increases machine availability. Industry 4.0 is already a reality today. Consistently distributed intelligence, open standards, and demand-oriented modular solutions. The connection between people, processes, and products makes your enterprise quicker, more flexible, and more efficient. Talk to Bosch Rexroth about connected automation now.